Okay, good afternoon once again, and thanks to join a session on hardware interfacing and IoT with Matlab. So in this session, we'll see how to interface the hardware. So right now, you will be not able to see hardware. So what I will do, I will show you how to interface the Android mobile and how to log Android sensor data. Similar way, I will show you if you have different kind of hardware, how are you going to interface. We'll see the step-by-step process, and further we'll see one IoT application also. If you have to log sensor data on internet cloud, then how you are going to do that kind of task. Fine. Okay. So about MATLAB, some features about MATLAB. Let me show you based on the hardwares. You can use with over 1000 common hardware devices for more than 130 hardware vendors in MATLAB. So lots of hardwares are supported. Either if I am talking about low cost hardware as we discussed, or some embedded hardwares or a PGA kind of hardwares, you can integrate MATLAB into your production analytics applications also. Already we discussed about that you need not to worry about functions in MATLAB. They are 1000 times each and every functions are tested, and you need not to worry about accuracy, and you can create your models. You can integrate with production analytics, or you can integrate MATLAB algorithm with other languages also, like C, C++, Java, .NET, Python. You can create Python packages also. If you want to run Python in MATLAB, that also you can do. You can run algorithm faster. If you have a big data, then you can scale your data up to clusters, and you can run your iterations on GPUs also. You can plug into Simulink and Stateflow for simulation and model based design. So already we saw some models in Simulink, right? So model based design is nothing, just testing of your model virtually in a different way. Okay, so this is not our agenda for model based design today, so we are not going to discuss about that. So automatically you can convert MATLAB code to embedded C, CUDA and HDL code also. So we have coders in MATLAB to generate these codes, because when you are going to deploy in a hardware, we require a specific code, not a direct MATLAB code we can deploy. So in MATLAB we can do things directly, means we can convert embedded code, and further we can deploy in a hardware as well. So this is some agenda which we are going to see here. So overview on IoT application, this we are going to see in this session. Let me show you what we are going to see first of all. So we'll see why overview on IoT applications in electrical industries. Also we will see how to, we already saw this one, right? How to create Windows app. We are going to see this one, how to interface hardware with in MATLAB and Simulink. Further we will see how to create Android apps using MATLAB and Simulink. This is the demo on ThingSpeak. I will show you if you have to create some kind of forecasting model. We are logging data from sensor, and we have to forecast based on that sensor data how we can do that kind of task. One demo I will show you about fault detection. Let's say that if you have any device and there some sensors are installed, like GPS sensor, vision sensor, and if that device is fallen somewhere, then it will give you a location that your device is fallen somewhere, or somebody is stolen your device, then you want that where your device is there. So you can create your GPS systems also. That's all which we are going to see for today. So first of all, we'll start from the case study about IoT. So this Tata Steel company, you are aware, everyone knows about Tata Steel company, right? So what they did, they saved the 40% energy on cooling towers through software algorithms. So Tata Steel basically they built irons and raw materials to make steel from that. So in that case, when they melt it, lots of heats are generated. So to cool that kind of things, to cool that machines, they require a cooling towers. So the Tata Steel Group is among the top global steel companies with an annual crude steel capacity of 27.5 million tons per annum. It is a geographically diversified steel producer with operating in 26 countries and a commercial presence in over 50 countries right now. So they have cooling towers for that plants, 200 cooling towers plants, cooling towers they have in the at its plants across the world. These are medium and high capacity cooling towers, means as high like 1000 tons of refrigeration cooling towers they have. So what was the challenge? First of all, that Tata Steel was looking for a way to improve the efficiency of the cooling towers to reduce the energy consumption and save the cost again. So you know that let's say I have such kind of plants, and to cool that some part of the plants, let's say I require some fans for that. Okay, and based on the temperature of that heat I want to on my fans. Let's say I have 10 fans. If I am talking about, let's say I want to on 5 fans based on the temperature, then manually what I have to do, I have to measure the temperature, then I have to on that kind of fans. Let's say it is very high the temperature, then I have to on 10 fans, right? So what is the problem here, that even if I require to on only 4 fans, but 10 fans will be on, so there is a loss of energy, right? So we require some kind of dynamic model or some kind of automatic controller that automatically it will sense the temperature, and based on that that cooling towers or fans will be on. So Mr. Data Sarkar, he is one of them from there. If we can reduce the energy consumption of the pump and the cooling fan, then energy will be saved significantly. To do that, we have to install the VFD, variable frequency drive, instead of the control valve. So they were using before control valve, so that was a mechanical kind of thing, so lots of energy was consumed in that case, even if they require to all cooling towers or some less cooling towers, but still there was not proper synchronization in that. So they designed a variable frequency drive using MATLAB. So what they did actually, the plant which they had in a real world, they designed the replica of this plant in a Simulink. Okay, same plant, already we saw physical components are available there, right? They designed the same plants virtually, that is called digital twin. Real plant and virtual plant, both if you design and if you do if you get the sensor data from real plant and do analysis in the virtual plant, that is called the digital twin. Okay, to do that, the digital twin model of VFD controller was created. The digital model is continuously updated based on data from the real world on the actual plant. So they were logging data from sensors from the real plant, and that data they were providing in the Simulink to that virtual plant, and based on that they optimize the controller, that is the variable frequency drive. Once they optimize, once they got the parameter, like in previous session we optimized the capacitors inductance values, right? So same way they optimize that using the controller, and once they got the parameters value, they designed a controller variable frequency drive for the real plant, and they applied for that. So it was easier for them to make a physical controller, that is VFD. It was more efficient for them. Now what is digital twin? A digital twin is an up-to-date representation, a model of an actual physical asset in operation. It reflects the current asset conditions and includes the relevant historical data about the asset. Digital twins can be used to evaluate the current condition of the asset and, more importantly, predict future behavior, refine the control, or optimize the operation. So as I said, you will have a real plant. You are going to create a replica of that plant in a virtual environment, that is Simulink in MATLAB. And once you have virtual plant, you will log the real data, and you can predict the behavior of your system, that how your system is going to behave in the future, or maybe you will predict that which component is going to stop in the future, so you will have a backup in advance, right? So using digital twin, you can analyze the system characteristics, you can take some intelligent decisions, you can optimize the system using digital twin, or you can monitor the health of the system also, right? How digital twin work? Create a virtual plant in Simulink. We have components libraries available: electrical, drive line, multi-body fluids. Once you have created, you will log the data from the real plants. You will have a sensors in real plant. From the sensors you will log the data in MATLAB, and you will create some kind of predictive or data driven modeling, that is predictive or forecasting kind of model, to check the system response in the future. So applications of digital twin like operations optimization, predictive maintenance, anomaly detection, or fault isolation. Like already we discussed the first one, operation optimization. This enables the system operations to be optimized or controlled during operation to mitigate risk, reduce cost, or gain any number of system efficiency. For example, about fan speed, let's say that if I am saying that based on the temperature, how much my fan speed will be, for example. So if you have a digital twin, you can do such kind of tasks, right? Predictive maintenance, once you get the data from the sensor, you can create some kind of data driven model like for predictive or forecasting model, and based on that you can find out that which component is going to stop. Like if based on the data, let's say that you measure the RPM. Of course if there is some issues in your machine, then RPM value will be changed, frequency will be changed, right? So once you get that it is not in a normal operation, like you can predict that maintenance needed, so you can do a predictive kind of things, right? Anomaly detection, sudden detection in your power grid. Let's say that there is some kind of unresponsive behavior from based on the sensor data, then you can change that component, or you can shut down that system, right? Fault detection, like as I already we discussed, that is a predictive maintenance. So if you have to detect the fault, so manually to detect the fault, and if let's say that some kind of fault happened, and because of that fault your complete system will be shut down suddenly. So to minimize that kind of things, we can again use the digital twin, and we can log the data. We can do analysis on virtual plant, that if there is any false detection also. Once you get that if there is fault, you can isolate that fault from there. Digital twin with MATLAB. So we have complete solution in MATLAB for digital twin. So smart assets, you can interface any kind of assets, either you have a real plant, or if you are designing the virtual, as it is virtual in that. AS system, where sensors will be installed, so you can interface hardware, you can log the sensor data. OT systems and IT systems means once we are getting the data from that sensors, then where are you going to log that data, where are you going to save that set data, right? That is very important. So in MATLAB we provide a solution to design a prototype model using the ThingSpeak, and people are using ThingSpeak in industries as well. So the ThingSpeak is a internet cloud where we can log the data from sensors, and further based on the data, if you have to do some kind of analysis, so we have lots of modules and algorithms available. So depends on you that what do you want to do with that data, and what kind of models are you going to create based on the data, either for the predictive maintenance, false isolation, or for optimization of your system. So depends on you. So this complete solution we have in MATLAB, and you can design that. Now, what is the Internet of Things? The Internet of Things is the internetworking of physical devices, vehicles, referred to as connected devices and smart devices. Internet of Things is basically the interconnection of different devices. It can be buildings, it can be embedded hardwares, it can be softwares, it can be sensors, it can be actuators, it can be vehicles, it can be a traffic area, anything it can be. They can connect with each other, and they can communicate with each other, they can exchange data also with each other. So IIT, Industrial Internet of Things, is a one application of the IoT. So industrial IoT represents a variety of IoT applications, smart production design principles, and data-driven automation practices in the industrial sector of economy. So means if I'm talking about industrial IoT, from production to client, everything will be connected with each other. That is called the industrial IoT. So nowadays in some vehicles, when you buy the some vendors provide sensor based vehicles. So how you are driving and what the way you are driving, where you are driving, the data will they company I mean which they manufacture that vehicles, they'll log that data, and based on that data they find out the your driving style and where you are driving, and based on that data they optimize their vehicles, that okay, he's driving in this way or she is driving on that way, this is the driving style. Using all that things you can optimize your vehicle. So that's a very beneficial for industries, that they can predict the future behavior of the system, and based on that they can optimize their products, right? So this is the basic components of the IoT. Three nodes we require for the IoT. First node, if I'm talking about, that is a edge node where sensors are installed. Okay, so edge node where our sensors are installed. So sensors, edge node can be a smart node or dump node. A smart node means the nodes which you can control. Smart node, the node which you can control, that is called a smart node. Dump node means once you deploy your model, you can't control. Like Arduino, if I am talking, or Raspberry Arduino. In Arduino, in the case of Arduino, once you deploy your model, you can't modify it. Either you what you can do, you can rebuild it again, right? But smart node like Android mobile, that is a smart node. You can control through that smart nodes. Once you get the sensor data from there, you have to log on the data aggregator. Okay, so once you have data in a data aggregator, you require a exploratory analysis system like MATLAB in this case. So once you get the data, based on the data you will do some kind of analysis and analytics, and you will find out the what is the behavior of your system in the future, or if you have to optimize your model, depends on you. So three basic nodes we require: edge node where your sensors will be installed, data aggregator where your data will be logged, and exploratory analysis where you are doing some kind of analysis there. So market driving IoT, where what are the applications of IoT and where you can use this kind of applications. Smart cities, we can't imagine any smart city without IoT and IoT system, and we can't imagine IoT without data, we can't imagine data without sensors, right? And we can't imagine various sensors, lots of sensors without high speed internet. So when 5G will be installed, then speed will be enhanced, and thousands of sensors data you can log at a time, and you can do some kind of analysis after fusion of that sensors. Connected cars, smart meters. So if you have a smart power meters at your home, then what will happen in that case, that every day your meter reading will go to the meter company who is meter vendor. So in that case, a meter man will not come at your home to measure the meter readings and all these things. Automatically it will go and they will send you a bill. So you know that one job is gone of that meter man who was coming to read the meter reading data, right? So but one job is introduced, that is IoT engineer, right? Wearables like healthcare devices which you wear, personal technology. If I'm talking about a healthcare, let's say that you have some issue or someone has some issues like BP, blood pressure issue. So what he will do, he will go to the doctor. Doctor will measure the blood pressure, and he will find out the reason of that. Then he will prescribe some medicine, right? So if that device, if you have such a device which is connected through IoT, and when you use that device on your body, then automatically BP data will go to the doctor. I mean, you don't have to visit to the doctor, right? Actually, so once he will get the data, and one he will have some kind of data driven model. Based on that, it will automatically predict that what is the reason for high BP or low BP in that case. Machine to machine industrial IoT, already we discussed. So right now, let's say that I have one plant, and I have to log data from one machine to other machine. So what will I do? I will note the data from one machine, then I will upload that data to the other machine manually. But if both can communicate with each other, both machine, then you don't have to upload data manually. Automatically data will be synchronized, and they can communicate with each other, and data will be uploaded. So in that case, one job will be gone, the person who was uploading the data, right? But one job is introduced as a IoT engineer again. Smart agriculture. Smart agriculture, like let's say that I have to do agriculture, but I am not a farmer. I don't know how to do agriculture, right? I don't know when to pump the water, and when to not to pump the water there in the field. So if you have a such kind of device which is connected through IoT, you can use some kind of soil sensors. Based on the threshold value of that soil sensors, automatically water pump will be on, and water pump will be off. This is smart agriculture. You don't have to do anything. IoT will do for you everything, right? By McKinsey study, from their survey, they told that IoT will be an $11.1 trillion market by 2025. So you can imagine the future of IoT, right? IoT and AI. These are the some challenges of IoT, because we require a complete notes and to design that complete IoT. Hard to get started. Complex systems are there. How you will start? From where you will start? From where you will get the data aggregator? There is a no single vendor solution that will provide the complete IoT. But nowadays they provide the complete IoT system, but it is very expensive. Very, very, very expensive nowadays. Multiple expertise required to build a system, right? You have to be a communication, how to you will communicate, I mean, from the transmitting into the receiver end. How will you do data analysis? How you will publish that data on website, the result of that? For the analytics, you will require data scientists for that also. So lack of consolidation on industry and standards, because it is very new. That's why there is a lack of consolidation on industry and standards also. So this kind of things, how you are going to do? You are not a IoT engineer, you are not a data scientist, you are not a communication engineer, right? You are not a IT engineer. Then how you this can be sort out this thing? So you can use MATLAB to sort out all these things. You don't require to be a big data scientist. You don't require to be a communication engineer. Everything MATLAB will do for you. The things is that you require that the thing which you want, that have to be achieved. Same things industries wants from engineers as well. So for that, for data aggregator, we have ThingSpeak in MATLAB, that is free for a student. You can interface hardware, which we are going to see. For the analysis part, we have machine learning, deep learning, lots of modules are available. Signal processing is there, DSP is there, right? So let me show you that first what is the ThingSpeak, then we will see that how it works. So what is ThingSpeak here? Typically used to collect data from sensors, provide instant visualization of the data, popular for people experimenting in the IoT, has more than 1 lakh users. They use ThingSpeak to log their data, can be used to analyze data. New MATLAB integration allow users to run scheduled MATLAB code on data coming on the ThingSpeak. You can schedule your code also. You can write the code also there, that what do you want with that data. Can be used to act on data. You can tweet. Let's say that I have a temperature sensor, and if it reach more than 40, then I want that it will tweet for me. So you can interface with social websites also, like Twitter, Twilio, right? Who is ThingSpeak for today? Makers, education, engineers, prototyping, and in the industries also they are using. This is the link for the ThingSpeak. So if you open the ThingSpeak, it will be open like this. Let me switch here. and open the ThingSpeak here. So simple, you have to write the thingspeak.com. This is the ThingSpeak. Okay, here lots of channels are available there. Let's say I am going in public channel and I am going to search that if there are such channel installed in India or not. Just I will search here and I will submit this. And you see that lots of channels which are installed in India are showing here. Let's say I'm going to click on some channel here like air sensor. So you see that there are different fields are available. Field 1 is the temperature, field 2 is the humidity, right? Field 4 is the chart. Now let's say that I have to read data from this channel. Means I want to read this temperature from here. Okay, in Matlab. So what I require here, I am going to switch here. There is a command. First of all, I want the data and at what time this data was logged. ThingSpeak read command, channel ID I require. So if I switch here, I have this channel ID. Now from which field I am going to read? Field number 1, that is temperatures. When I run this, I will get the data, last data which is uploaded. So the temperature is showing 32 degrees centigrade and what time it was logged, that is 12:15, and this is the date where this data was logged. Let's say that I want this data from field 1 and I don't want only 1 points only, number of points. Let's say I want 30 data. Okay, so when I run this, I will get that data here. So I have this data and time. If I plot this, plot time and data, and I can visualize that. See, this is the temperature, how it is varying. Last 30 data from there, how it is logged. Once you have data, you can do some kind of analysis on this, right? How to create your channel? Just go here in channel, in my channel, and from here you have to click the new channel. Already I have created many channels, so I am not going to create it again. Just I am going to show you how to. When you click on the new channel, it will be open like this. Okay, so this is a channel name. Here you have to provide a description and how, at a time how many data are you going to log. Just you have to tick and untick. Let's say that I have an accelerometer sensor, so I will have x-axis acceleration, y-axis and z-axis. So I take 3 here, right? Let's say x-axis, this is y-axis, and this is z-axis acceleration, something like that. Once you have done this, you can provide the metadata, from where metadata something like that. You want message that if threshold value reached, then it will display that. Tag, so people can search you from that tag. For this project, if you have an external site, you can provide that. And GitHub, if you have project on GitHub, then you can provide the GitHub. Elevation, how up sensor is installed, right? Elevation, how it is elevated, where your sensor is installed. Location, latitude, longitude. If you have some YouTube video, you can provide the link, and further you can click the save the channel. Okay, let me clear this channel data first of all. From here, clear the channel. So when you save this channel, you will get 3 fields here. So field number 1, field number 2, field number 3, right? Okay. And now let's say that I have to connect this channel with Google Assistant. So already I have connected here. Let me show you how to do this task. I am going in my channel and I am going to open this. I want to connect this with Google Assistant. Let's say if I say that light my fire, light on the lamp, so this lamp will be on. If I say off the lamp, this lamp will be off. So how to create this kind of lamp? So here is the option add widgets. So from here you can use the lamp, you can use numeric display, or you can use ghost from here as well. Okay, so I added it here. Now if I go in API key, here is the link that how you are going to connect with Google Assistant, or you can connect with Alexa also. So it depends on you. To write a channel feed, to read the channel feed, you can use these links. Okay, one way to do this, there is one FFT that is called if this then that. You have to register here. Once you register here, these are the applets which I created here. Okay, if we have to click the create. You have to log in on IFTTT. You have to create. Okay, once you do this, if this, then do that, then that. So first of all, you will start from if this and search Google Assistant. Here is the Google Assistant. Start with the simple phrase word. So here what you want to say to Google Assistant, here you have to write it. Okay, so once you write different words, different phrases, you can write it here and create a trigger for that. Okay, so once you create a trigger, when you say the Google Assistant, it will be executed. So already I have created two things, one to write one there to on the lamp, one to off the lamp. Let me show you one how I have created here. See here, what do you want to say? Kill the lamp, off the lamp. Another way to say, different ways you can write. Further, this ID, when I say kill the lamp, I want that lamp will be off. So what I am doing here, you see here, this link already which I was telling about this link. Sorry, just wait a minute. Here, not this one, this link. And the field value will be here 0 value. Just I copy pasted there. Here. Okay. So if I say kill the lamp, I want that on this channel 1 will be written. Then I will provide 1 here instead of 0. Okay. Same way. This is for the off the lamp, and to on that lamp, I provided one more API here. Light my fire, something like that. So if I go in the setting, same thing, light my fire. In that case, kill the lamp. Here, light my fire on all lamp or on the lamp. And here you see method is get, and here is the same link, and here value is 1. Okay, now I am switching here, and when I open this, here you see what I have done here. Field 1 is greater than 0, then this lamp will be on. If it's smaller than 0, then lamp will be on. So when I say kill the lamp, it will be off. When I say on the lamp, then 1 value will go and it will be on. And further you can use this to control any device also. So let me check it if it is working or not. So I am going to open the Google Assistant. On the lamp. So let's see that this lamp will be on or not. Sometimes it depends on the internet connection also. If internet is slow, then it takes a little time. You see that this lamp is on. Now I want to off this lamp. Off the lamp.
Here's a matching video.
Off the lamp. Off, kill the lamp.
I can say,
Kill the lamp.
okay, performing action.
So now you see that when I said the kill the lamp, and this lamp is off, and the value is written here from Google Assistant. 1 on and off. This is 0. Now one thing more you see here, I have data in the ThingSpeak. I can create such kind of models. I can deploy this ThingSpeak in any hardware. When I say on, then my machine will be on. When I say off, then machine will be off, right? So how to do this kind of things, we are going to see that. So you are aware about ThingSpeak. To register on ThingSpeak, you require a MathWorks account. Just log in with the MathWorks account. This is the MathWorks products and you will get that. You can provide the locations also where this sensor is installed. Okay, now how to deploy hardware in the sensor. The first step, what we are going to do, first of all, whatever hardware you are going to interface with MATLAB, you require a support packages for that, and that support packages are free. You have to click here in add-on. In add-on, get hardware support packages. Once I will click here, this is more about hardware interfacing rather than IoT. You see that their support packages are showing. I want support packages for Android. So simply here I will type Android and I will enter. And here it is open sibling support package for Android devices. I will click this. I have installed this support packages already. When you do a first time, here option you will get to install. So once you install the support packages, so you see that there are different hardware options are there available, right? Different hardwares are there. I want here this, you see that this are, I want hardwares related to signal processing only. So just I will click signal processing. I will get the hardware for the signal processing, like MATLAB support package for Arduino. I want a support pack. I want to interface the Raspberry Pi. Just simply I will type the Raspberry, and I will get the support packages for Raspberry Pi here, and I have to install that support packages. Okay. Now once you install the support packages, you will get the library for that. So see, if I scroll this below, Simulink support package for Android. See, I have libraries here, audio and video libraries. If you have to capture audio data from Android mobile, or if you have to read audio file, or if you have to write the audio file, I want to play something, or I want to lock camera from my Android mobile remotely, so that also we can do it. And video display if I have to do more. You see sensors. These sensors you will have in your smart mobile. If you have to log the sensor data, you can log the sensor data. The first step is to install the support packages. Once you install the support packages, you have to configure your hardware with the MATLAB. So these configurations you have to do only one time. Okay, just wait a minute. Let me connect my Android mobile first of all. So okay, it is connected right now. Okay, once you install the support packages, you have to go again in add-on, and you have to click here manage add-on. In manage add-on, I want to interface Android mobile, so I am going to configure the Android mobile. Okay, so here I will search Android. Perfect. So here I am going to configure this. So here is the option to set up this Android mobile. Okay, so from here you can set up this Android mobile. Now it's saying that you have to install the Android Studio. Okay, here it is written. So you have to follow these steps. So when you click on this, it will redirect to Android Studio. You have to install the Android Studio from there. This is the first step which you have to do. From here, download and install that. Once you install that Android Studio, check this, it is installed or not. So it's showing verification successful, it is installed. Then next you have to do next. Now here it is showing telling you open the Android Studio and install the Android SDK platform. So when I click on this link, I have already configured. So when you open your Android Studio, it will be open like that. You have to go in the SDK manager from there, and from there you have to install all these packages there inside the Android Studio. Okay, so from here you can select and do OK, and it will be installed. So once it is installed, let's verify that. Okay, it is verified now. Next step, it's saying go in the system of your Android mobile, setting, system, about device, there is a build number. It's saying that click on this build number 7 times. Once you click this 7 times, you will get Android developer option. Okay, so from the Android developer option, you have to on the USB debugging. Tick this. That's all. To create a .tpk file, you have to on the USB debugging. So it will be deployed there. Okay. Once USB debugging is on, do the next. Now it says that the what kind of mobile model do you have? What vendor model do you have? I don't have Samsung. I don't have Google device. I have different device, and I have installed that driver of that. Do the next. Now it says that it will ask you some permission in your Android mobile. Do it. Okay. Do the next. This process you have to do only one time. Then it's asking select your Android device. So it will search my Android model. So I have a Lenovo K8 which I am using. It is detected automatically. Then I will do the next. Now it says that make your Matlab machine and Android mobile in the same Wi-Fi. Why? Two things you require. Connect the USB through your laptop to deploy the model in an Android mobile. For the communication between Android mobile and your machine, you require some platform. So we are going to use Wi-Fi. If it is the same Wi-Fi, they can communicate with each other. Once this is done, do next and test this. What it will do, it will build the model and it will run the run the app in my Android mobile. Okay. Once it is done, then you will test the verification that connection is proper or not between Android and machine. So it will take a little time. So it will take a first time 4 to 5 minutes to do this task. So once you have configured this, you don't have to do anything. You can start deploying model in Android mobile, or you can start logging data in Android mobile. Meanwhile, if you have any questions, you can ask me. So while it is deploying, let's do something. Let's discuss about something more. So some common applications are there like tidal depth forecasting, temperature sensor logging, data logging, fault detection, Android control from Android, Arduino control from Android. These are some small applications which you can try. So we talked about the IFTTT also. It is a if this then that, also known as IFTTT, is a freeware application. I mean freeware. It is so you can use it for your purpose to connect with the Alexa or Google Assistant in this case. Okay, let me check. Do I have some error here or it is done? So now it is build and run. Now I am going to check that connection. Okay, done. Do the next and just finish this. Now we are going to create models. So first model I will show you how to interface hardware and log sensor data. Same way you are going to do for Arduino also or Raspberry Pi also. Okay, so I am going to open a Simulink blank model. And I am going to open here, and from here I will go in the library. Let's say I want to log accelerometer sensor data. Just I will select this. Fine. And once I have this accelerometer sensor here, I will zoom this, and you see here in Arduino what kind of blocks we have. We have some common blocks, analog input, analog output, digital output blocks available there. And if I go in Ethernet shield, so here you see we have a ThingSpeak read and write. If I have to read data from ThingSpeak, I will use this block. If I have to write data in ThingSpeak, I will use this block. So why to write in a Arduino hardware? Means to control something. Like if I give value 1, then some machine will be on. If I give value 0, then it will be off. To control the Arduino controller. Okay. So we have this accelerometer sensor. To display this output, we require one scope. Okay, we have this scope here. Now I am going to connect x-axis acceleration, y-axis acceleration, and z-axis acceleration. Sorry, here z-axis acceleration is connected. Just open this scope, and I don't want to visualize all acceleration values in the x-axis, y and z-axis acceleration in the same window. So I am going to create a sub windows for this from here, 3 like this. I have this. Okay, now next step is that on which hardware are we going to deploy this model. So for this we will go in modeling, and from here there is a model setting. Here is the model setting. Okay, so it is still opening. From this model setting we have to go here in hardware implementation. Now you can choose hardware from where, that on which hardware are you going to deploy this model. So different hardware, different Arduino models are also available, Dio, Lino, Mega, and if you have Raspberry Pi, you can select a Raspberry Pi also for that. And if I choose from here, we require an Android, so we have to deploy an Android device. I will select Android, and once you select this Android device, all configurations will be done automatically. You don't have to do anything. See this configuration, what will be a baud rate, and if you have ThingSpeak, if you are logging data from ThingSpeak, you can provide the IP address of that, right? This is a build option, and this is the baud rate here. And if I go in device option, what device I have, already it is detected from here, you see here. Perfect. And serial port properties, baud rate, all these things. So once you select this hardware, just apply this. Same thing you are going to do for a Raspberry Pi as well. So when you select the Raspberry Pi, automatically username and password will be detected, or you can provide manually. Okay, now it is connected. Once you connect this, you will get a hardware tab here. I am going to run for infinity loop, INF. I want to log the sensor data in my Simulink. So what will I do? I will just click from here, monitor and tune. So it will take a little time to deploy. First time when you deploy your model in a hardware, it takes time. So it will take 2-3 minutes around. So this and we can see that Android sensor data in this scope, that accelerometer sensor. So you see that it is generating the code, and it is optimizing and emitting the code. Now it is building, deployment is started. So now what it will do, it will generate the embedded code, C++ code, and that code will be automatically deployed there. So even if I'm talking about Java, if I'm talking about Android, everything is written in the embedded code. Okay. So soon it will start, so it will take a little time. More what you can do with this apps. If I go here in the all apps, if you have to do some kind of MATLAB analysis, so you can use some kind of analysis tab. Once you write a code in the analysis. Let's say that I am using this one, and here you can write the MATLAB code directly in the on the ThingSpeak. See the from which channel ID I am reading data, what is the field number, read API key, write API key. Once you have done, you will go in the my channel, and let's say that I am going here. You can add that visualization here. See, this is the visualization which is added, right? You can add the visualization. More apps, what more apps are available here? If you want to connect with the tutor, you can connect your tutor also. If you want to control that MATLAB visualization or MATLAB analysis program, you can use time control. And react, if you want to react on the data, means if some thresholds are reached, then it will be tweeted on the tutor or on the tulo. You can use this. So here you have to provide, if you click on the new react, here you have to provide log sensor data and ThingSpeak HTTP or MATLAB analysis, what you want, on which data are you going to react. You can choose this. And further, lots of time control. If you want to control that, you can use time control. If you want to write on your website this data, you can use ThingSTTP also. Okay, let me check this model is done or not. So this model is running. Here you see that x-axis, y-axis, z-axis acceleration we are getting. I am not moving my mobile, so x-axis acceleration is 0, y is also 0, but I am not moving mobile, but still I am getting z-axis acceleration somewhere around 10. You see here, right? This yellow color which you see. Why? That is a gravitational acceleration. That is 9.8, which is vertically applied on my mobile. That's why. Now I am going to move my mobile. I don't require any connection. You see that I am moving mobile, and you can see that based on that this accelerometer sensor data is also moving. Further, you can interface this accelerometer sensor data with any robots, and based on that this accelerometer sensor data, you can move your robots also, right? So this is the way how we are going to interface in this. Okay, I am going to close this. Next step, what I am going to do, this is the last, then we will end this session. After that, what I am going to do next, I am going in my channel, and I am going here. I am going to log my data here. Okay, so before that, whatever data is here, this is a historical data. When before I measure, I am going to clear this, clear this channel, and save. I am going to save this channel. So now we don't have any data. I want that I want to create a Android app. Whenever I will open that app from my Android mobile, my data will start logging here. That what I want right now. So what will I do? I will go in the same model. Okay, I will remove this scope, and from library browser, I will go in Simulink support package for Android, and I am going to use ThingSpeak write block. Okay, if I have to read data, if I have to visualize ThingSpeak data in my mobile, I will use ThingSpeak read, but I have to write this data. X-axis acceleration, y-axis and z-axis. So number of fields will be 3. It is asking me channel ID and API key. I will move here, and if I go in API key, sorry, this is the channel ID. I am going to paste it there. I need a write API key. So write API key is already here, and I am going to paste this also. Update interval in a free version, for each and every 5 seconds it start updating. So I am going to choose 15 seconds for free version. In paid version, every second you can update data. So minimum time is to update, that is update interval is 15 seconds. Once I have done this, and once I have provided this channel ID, in this case I am not going to log data in Simulink in my local system. I want to deploy a app in my Android mobile, and when I open that app, my data will start logging here. This I want right now. Perfect. Also, there is one lamp indicator here. I want, if my mobile is fallen, if someone is stolen and running with that, okay, from field number 1, x-axis acceleration. What I am going to do, if my mobile is moving, x-axis acceleration will increase, of course. So I want that if it is fallen, then x-axis acceleration will increase more than 2. If it is equal to 2 or it is greater than 2, then I want that it will blink as a red. Lamp will glow as a red. Fine. This also I want. Okay, so now what I am going to do here, I am going to open this. Okay, and in this case I have to deploy this model. I will go in the hardware tab, and in this case when I have to deploy any app in hardware, I will choose build, deploy and start. Once I will click this, it will start deploying there. So once it is deployed, I will get an app as a .apk, and it will be installed, and you can share that app with your colleagues as well. So here you can see the process also, what is going on. If there is some error, it will let you know. What it says that no Android device is connected to your host computer. Connect to Android device. Okay, I forgot to connect this again because I disconnected when I was moving my mobile. Let me connect this again and check that here it will be shown it is connected or not. Oh, I am going in this PC, so it is connected right now. Perfect. Again I am going to run this. So when you deploy this model, you require to connect your Android mobile with USB connection, and in the both have to be in the same Wi-Fi. And from developer option, you have to on the USB debugging. Okay, so meanwhile, if you have any questions, you can write in a chat box. So it is still deploying. So for the update time interval will be 15 seconds as a default. So minimum update time interval is 15 seconds in this case. So if I go here, and it is almost deployed, this model. Just wait for a minute. So it is now, this model is deployed. Okay, and now if I open this, and you see that after every 15 seconds data will start logging here. It is showing red because the value is 95. Right now it is 46 here. So I think somebody logged data here, that's why it is showing here. Let me refresh this. Now you see that this LED is off, right? Because the value is 0, because I am not moving my mobile. If somebody will steal my mobile, he will run with my mobile, or if my mobile is dropped, so I am shaking my mobile, I am not dropping, and soon this LED will glow if my mobile is fallen here. So you see that whenever I will open this app, I will be able to log data here. When I close this app, then data will stop logging. That's why it is a smart mobile that I can control from here, right? Let me refresh this, and you see that if value is more than 2, and this LED, this lamp is glowing, right? And if value is 0, this lamp will be off. So same way you can control from Android to Arduino or Raspberry Pi or any other big devices, because we have a ThingSpeak read block, so you can deploy that ThingSpeak read block in any hardware. Fine. Now you see that I am not moving my mobile, value is 0, so that's why this lamp indicator is off. Okay. The last example which I am going to show you, that is the fault detection. So this is the fault detection through IoT, through ThingSpeak. Let me show you what I have done here. So such kind of applications you can design for your projects also. or some small projects if you are working with that. So this kind of prototype models you can design with that. So let me open that model. So this is the model which you see right now here. So what is happening in this, I am logging accelerometer sensor data, I am logging Android sensor data, sorry, that is a GPS sensor, to get the location where my mobile is fallen and to on the camera of my mobile. Okay, so because I want a picture also that where it is fallen, and this is and you know here I provided some threshold value. When the x-axis acceleration will reach more than 12, this subsystem will be activated. Once it is activated, it will log my accelerometer sensor data, it will log my camera image, it will log the GPS sensor data. And once the same time I use this stop block, this block will be stopped as well. Same time a code will be executed. What code will be executed? I have written the stop functions. Just wait a minute. Let me show you where you can write the stop function. Here, when you go in the model explorer, go in the callback, and here is the stop function here. Stop function here. So I have written the code to display that on the map, to display the image and everything, right? So let me run this. So I want to log data in the Simulink. I will go here in the hardware, and from here I will run monitor and tune. Okay, I forgot to connect again my Android mobile. Let me connect this. Maybe I will get the error first time. Okay, it is connected now. So it is very simple. It will take only 1 to 2 hours only to design this application, if you even if you are a beginner. Just require 3 sensors data, and this create it as a subsystem. Use some threshold value when x-axis acceleration is greater than 12, because when your mobile will fall, automatically acceleration will increase, right? And the same time it will stop also, and write the code and it will display it. And if you want that it will email you also that where is the location of your device, so you can use MATLAB to mail also. There is functions available for that as well. So I will not fall my mobile, just I will shake it. I want that my acceleration will increase more than 12. That's all. That's all which I will do in this case. Okay. So various applications are there which you can design with IoT, and IoT can be used anywhere, any department. Either you are electrical, mechanical, IT, computer science. Okay. So almost it is deployed. So this time the latest version MATLAB which I am using, that is faster than previous one. So very soon it is deploying. Other before it was taking more time to do this task. Meanwhile, you can write a questions. If you have any query or questions, you can write in the chat box. So here you see that still it is building here which you see here, right? This one. So once you deploy, you will get an app in your Android mobile as well. So same way you can interface any kind of hardwares. You have to, now it is running. You see that it is running on Android device, right? So I am going to disconnect this USB connection. It is communicating through Wi-Fi, and I am going to shake this mobile, and within a minute it will give you a location, and it will give you an image, and what were the speed when your mobile was falling. That is the acceleration. At latitude and longitude value also you can visualize that where it is fallen. Okay. Apart from that, you can create such kind of applications also. If you have to already we got that how to interface, how to create a Windows app also we saw. So okay, before that let me show you this. See the location where my mobile is fallen. So here we can see the location that where my mobile is fallen, somewhere in the Delhi, somewhere near Kailash Hill, right? and here where it is fallen, this is the image, what is the latitude, longitude, and what is the acceleration. This is above 12, right? This is the speed also, that where it is fallen, right? So this kind of applications you can
Mask
design.
detected on face.
And you see that is a live mask detector.
Mask
So whenever
detected
we
on
have a
face.
session on deep learning, we'll discuss about
Mask
that.
detected on
So this
face.
is controlled through this
Mask
channel
detected on face.
I created. So when I
Mask detected
tell
on face.
Google Alexa that on this app
Mask
it will be
detected
on,
on
when I say
face.
off, sorry, Google
Mask
Assistant,
detected on
when I
face.
say off this app, it will be off. So in this case, you can create an Android app also. If you give the value 1, then that marks will be on. If you give value 0, then that marks app will be off. Okay, that was the session for today. And next, already we discussed, if you want to learn MATLAB, if you are a beginner for MATLAB, you can start from today. We have some courses available there. 8 courses are there. MATLAB on ramp, machine learning, deep learning, signal processing, image processing, state flow, and different control system modeling. So just let me share that everything, then we will discuss later.